Hello everyone from my side, and thank you for having me here. My name is Matteo Cafasso, and today I'm going to talk with you about RabbitMQ plugins. What are they, how to use them, and especially how to develop them. And I hope that at the end of this talk will be more clear to you how simple and fun it is to develop Rabbit plugins and how you can employ them to enhance the capability of our favorite broker as well as our architectures. Before we get started, just a little bit about myself. What do I do? So I'm a software engineer working in F-Secure Corporation, focusing on malware analysis automation, and more recently, especially in behavioral or dynamic malware analysis, which is that branch of malware analysis focusing in, executing the malware or executing the object in order to understand if it's malware or not. I know that doesn't sound brilliant, but it's a very effective way to detect malware nowadays. F-Secure is a 30-plus years old cybersecurity company developing several solutions to protect our customers. Among them, we have the more traditional EPP endpoint protection solution, also known as antivirus. Then we range throughout IoT security devices and such, ending more onto the enterprise level solution consisting of EDR, endpoint detection and response. And since more or less 2005, F-Secure has been heavily relying on cloud platforms and technologies in order to deliver protection to its end customers. Every day, our backends ingest a huge amount of data, which consists usually in samples, files or URLs which we need to quickly categorize in order to come up with a verdict. Is it malicious or is it safe? And more generic metadata, mostly consisting of events. So processes created and terminated, files created, memory or memory injection, DLL loaded in memory and such. And in our backend, we heavily rely, especially in the past, on RabbitMQ to provide messaging as a messaging system. We use it mostly as a task distribution mechanism, and also as a tool to basically as a pipeline to convey our events to these different data enrichment tools and feature extraction that eventually terminates on different AI technologies such as machine learning models and expert systems. So we started adopting, I believe, Rabbit back in 2010. And the reasons why we chose such a technology among the available were mainly two. First, Rabbit is a centralized broker. And in our architecture, this is very important because our architecture mostly consists of stateful architecture made of a lot of stateless microservices. And in such complex architectures, having a centralized communication system, which we can actually look at, really helps us understanding how our automation is doing. It helps a lot when we need to deal with problems and escalations. And these problems and escalation, the reason might vary. Sometimes it's self-inflicted pain, of course, some code error or configuration error. And many times as our backends heavily are tightly coupled with what happens out there on the internet, it might due to some phenomena out there on the internet, such as an aggressive malware spreading or a particularly big Windows update. I sometimes fail to see the difference between a malware escalation and a Windows update, but that's a personal opinion, so take it like that. And whenever these kind of things happen, we quickly learn that one of the first systems to show symptoms was RabbitMQ. What we would observe is a huge spike in the size of our queues, that the size would literally skyrocket, one or more of the queues. And these really helped us becoming more responsive towards problems and also identifying, okay, what was the suffering, which were the suffering point within our architecture. At a certain point, we grew so sensitive to Rabbit queues that one of the best way to actually trigger a panic attack to one of our colleagues simply consisted on walking to his workstation, to his workplace, and you would walk there and say like, hey, do you remember that service you once developed? Yeah, that one. There are 2 million entries in its RabbitMQ. RabbitQ. Do you think is everything all right? So that was one of the best way to actually ruin someone's day. So the bottom line is that sometimes somewhere RabbitQs matters in people's life. So this is the learning. And of course, another reason why we chose the RabbitMQ was due to the amount of features that the broker already back then supported. And this is thanks to its plugin-based infrastructure or architecture. In this slide, I try to condensate a few of those plugins which I managed to find on the internet. Some of them come from the Rabbit website. Others were collected either on GitHub or on GitLab. There might be some deprecated or unmaintained plugin there anymore. This is just to give an idea of the amount of features that the broker supports through plugin. And I highlighted in red those which are known as core or tier 1 plugins. Those are the plugins which get shipped, they get maintained and developed by the core team and get shipped all together with the broker once you install it. How to install a Rabbit plugin is usually pretty simple. They come as EZ files. They are Erlang archive files. So you just need to grab it and drop it in the default plugins folder, which varies across installation, so you can check the documentation. And then you can use the Rabbit plugin tool in order to enable, disable them, and interact with them. So jumping to a small demo. Can you see these at the end of the room? I guess it's fine. This is one example of a Rabbit plugin. It's the most known one, is the management plugin. And it simply consists on a web server running alongside with a broker and interfacing with it. It allows users to, it gathers metrics so that the user can actually monitor the status of the broker. We can see how many nodes are composing the cluster, how are the queues doing and exchanges, how many messages coming in and out. And we can also use it for interacting with the broker, so we can create objects, publish messages, and so on. It comes also with REST APIs, which are visible back here. So these can be used for interacting with a broker in a programmatic way. You can build your own scripts and use them to interface with a broker. Now, it's undeniable that these, when we were choosing which technology, which broker technology to use back then, was one of the main selling points. And to understand these, we need to understand what we were doing before in F-Secure. We were using an in-house build system called LAMP, so yet another animal. It was a peer-to-peer message distribution system, and it was a fairly good distribution system. To tell you how good it was, when I joined the company back in 2012, the main motto at the time was we need to kill the LAMP, and not because we are brutes, but because RabbitMQ was taking over. And as we speak, it's almost 2019, and I know there are pretty many LAMP instances still running wildly across our backend. So this is how difficult it is sometimes to get rid of things which work when you're dealing with live backends and live architectures. And one of the reasons why this was quite wow for us when we first brought it up is like we can really see what is happening, is that LAMP did not provide any UI back then. And the reason is pretty simple. It was maintained by few people. There were not enough resources to bring up a UI for interacting with a messaging system. And this is why I think, or one of the reasons I think RabbitMQ is this successful. I'm personally a fan of plugin-based architecture because I find that it's a very effective way to deal especially with open source projects. What we usually observe, or what we learn as open source developers, is that if our technology gets popular, all of a sudden we get overwhelmed by a huge amount of feature requests. And the more traditional way to actually tackle this problem is picking every feature and building it in our technology, which usually leads to the size of our core team growing, but these scale up to a certain point, because beyond that, the human overhead becomes very difficult to manage. Another strategy that we can do is provide well-defined and well-documented interfaces and let the community of users actually use these interfaces to build their value on top of our solution. And all of a sudden, users become contributors. And I find this very interesting because it enables our core team to remain small and agile and focus what really matters: security, code quality, performance, scalability, documentation. These are all those things which a core team should really tackle. And this is one of the reasons why I think RabbitMQ achieves such a longevity as an open source project, and why it is so successful. So jumping back to our presentation, what I would like to do with you today is actually developing a Rabbit plugin. So it's going to be easy. It's going to be a Hello World plugin, very simple. But before doing that, we should understand when it makes sense to develop a Rabbit plugin, right? So what usually happens when we adopt a technology within an architecture is that hopefully this technology starts producing value since the get-go. And the more we use it within our systems, and the more value it produces, up until we come up with a use case where this technology is not a good fit anymore. So what we can do is choose another technology and run it alongside with the current technology we're using it. Or we try to solve the problem by developing. And a common mistake that we usually do as developers is that when we come up with something, we build it on top of the solution rather than building with the solution or within the solution. And in open source world, I think this is a very, very bad mistake. So what we did, for example, in F-Secure back then, as I said before, we were using RabbitMQ as a task distribution service. And we immediately realized we need priority supports over our tasks. And back then, this was a feature that Rabbit did not have. What we did was to build our prioritization protocol, consisting in taking each and every queue and splitting in multiple queues. And each of these sub-queues would consist in a priority level. And then we would build libraries, which would, on the publisher and the consumer side, would be aware of this special topology, this specific topology. And they would use it. So what we did was basically taking a responsibility, a feature, and spreading it all across our architecture. And of course, as you might guess, this became a maintenance nightmare on a long run, because each and every node was supposed to play the game within the rules. Otherwise, things would break very badly. So a much cheaper, much affordable solution would have consisted in actually building this feature within the broker. First step as a plugin, and maybe pushing it to become a core feature. And luckily, someone else realized the same. So later on, a RabbitMQ plugin implementing priority queues came out, and now this is a core feature of the broker. You might have heard that Rabbit is developed in Erlang, and I wish I had the time to actually go through some of the Erlang design principles. But due to time reason, we can't really get there. So what I did was providing what I believe is a good description of what a Rabbit plugin is from a development perspective. And I put good care in placing in the slide all those keywords, which I think any developer which is not familiar with Erlang should look at. So what a plugin is, what a Rabbit plugin is an Erlang application consisting on one or more processes, supervised processes, which would interface with a broker either via message passing, and with messages here I mean Erlang messages, not Rabbit messages, or by implementing behaviors within modules and registering these modules within the broker, so that the broker could actually use our interfaces to extend its capabilities. Jumping more on the actual getting our hands dirty, so we need first, of course, to set up our development environment. As you can see, the dependencies are few. The most important one is, of course, Make. So Rabbit uses Make tool for building its platform, and more precisely, they recently, I believe it was version 3.5, they recently moved to this Make tool called Erlang.mk. Is a very powerful build tool for the Erlang environments. So what we will start with, of course, is our make file, which we place in the root folder. As you can see, it's pretty simple. We just define the project name and few dependencies. Ignore the gibberish in the middle. Just copy paste that. Trust me, I'm an engineer. I know what I'm doing. So just copy that. It will just works. And at the end, we need to include 2 external make files where the actual heavy lifting part of the building happens. So the RabbitMQ components makefile and the Erlang.mk makefile. You can find them in the projects, in the links. So you just copy them alongside with your makefile, and you're pretty much done. So you start with a project with 3 makefiles, and that's it. So a few commands. We will first run make, and these will, of course, aggregate and fetch all the dependencies and build them for us. This is the first step we always need to do when we start with Rabbit plugins. And then once that is done, what we can do is run the command make run broker. It will actually compile our code and fire up a broker for us. And if we provide any plugin, these plugins will be actually started alongside with the broker, so we can start really playing with the code, interacting with the broker, and see what goes wrong and what doesn't. I guess you know what make tests does. And lastly, when we are confident about our piece of art and we want to distribute it to the people, what we can do is using make dist. It will provide one of these EZ files I mentioned before, and you can just give that to your end users. Few steps more we need to take if we are building our plugins in a different language called Elixir. Elixir is a fairly new, fairly modern language, fully compatible with Erlang because it builds on top of the Erlang Virtual Machine. And at the time I wanted to give it a try, and this is one of the main reasons I'm giving this talk, because the main challenge I faced back then was how do we make the build tools cooperate together. Elixir, like many modern languages, got few things good from the get-go, and among them they provide their own build tool, so that you don't need to Google which build tool shall I use, how do I run test. Everything is done with a tool called Mix. And when we use Mix, the first thing we usually do is providing a mix.exs file, which is just a script describing our application. So my challenge back then was, how do I make these 2 things, the Erlang MK and the Mix, work together? Turns out it's pretty simple once you know what to do, as always, but it took me quite a few times. So this is just a part of the Mix script. I didn't include it all. All we need to do, all the magic happens in the depths function. In there, we just need to instruct Mix to ignore all those dependencies which the Erlang MK takes care of, like, for example, Rabbit. And we do it by passing 2 keywords, the path, where we specify where we can find already. We specify there where we can find the dependency already. Usually they end up under the depths folder. And then the compile keyword, that includes a command which would be issued in order to build actually the source code. So we just need to pass a no-op there. I'm using the colon, which is a typical no-op in Bash, but any command which would not produce any outcome works well. So next step, we need to slightly modify our makefile. The only thing which changes in the middle, we add an up rule, and in there we call the mix command. So mix depth get, that will actually fetch all the dependencies, ignoring the Rabbit's one, and then depth compile will do the same. It compiles them, skipping Rabbit dependencies, and compile eventually actually compiles our application. So also with Elixir, we're done with the bureaucracy. We can actually jump on the real code, but then the next question is, like, how do we actually glue our code with Rabbit? As I said before, usually a plugin is an Erlang application, so we need to find a way to start our application all together with the rest of the Rabbit components. And it turns out that it's pretty well documented how to do that, and I'll try to show you an image. It turns out Erlang Bootstrap is a real deal, is quite complicated, as you might see. Don't get overwhelmed by this picture. I couldn't fit in the slide either. The idea is you read this from top down, and you can be considered either time-wise, like what happens as a timeline, or also as a dependency graph. So it turns out that Rabbit splits each and every boot procedure in a boot step, which can be seen as a node in a graph. So each boot step brings up the specific resources you're in need. So here you can see when all the exchanges are brought up. And usually a Bootstrap requires a parent node, which is what should be run right before my Bootstrap, and optionally enable a leaf node. So in this way, we can actually ensure that our plugin has the time to start up before the rest of the components come up and Rabbit starts serving requests, because the Rabbit boots procedure is asynchronous, is concurrent. So this is all we need to do. Code-wise, this is a Elixir code base, but in Erlang would be pretty similar. All we need to do is to register a module attribute called RabbitBootstep, and in this way we inform the broker that, hey, this actual module includes instruction on how to fire up our application. And the RabbitBootstep describes what needs to be done. We need to include the module. In this case is the module itself, the Elixir module itself, and then a keyword list with a description, an MFA, module function argument. This is the entry point. This is where we specify how to fire up our application. So in here we start our processes, we bring up any database schema we need, and we connect with anything we need. And last mandatory keyword is the requires keyword, where we actually place ourselves in the dependency tree, which I showed before. We can optionally also pass an enables key so that we can make sure that our plugin, our boot procedure, is a blocking procedure, so the broker does not proceed until we're not done. As you might guess, we just print hello world in this case, just to keep it simple. And let me show you these very quickly, if I get the right screen. So what I will do is actually stopping the Rabbit broker that I was running beforehand. And as I said before, all we need to run is make run broker. I already run make before, so that you don't have to stare at a screen moving where all the dependencies are fetched. And hopefully what happens is that everything is compiled, and at the end we see our little bunny ASCII code in here, meaning that the broker is up and running, and our hello world is successfully printed. So we are basically done. Our plugin is built. At the end we can see that the Bootstrap completed with one plugin, basically telling us that our plugin was successfully loaded within the broker. So where to go next? Unfortunately, there's not much more to read in terms of documentation. The source is your friend. Out there are plenty of Rabbit plugins that you can look at in order to better understand how to do things. You can either copy-paste them or try to read and understand. One repository which will become pretty relevant since the get-go is the RabbitMQ Commons repository. That's where all the common data structure and behaviors or interfaces are actually provided. Among the behaviors, some honorable mentions, the Rabbit exchange type, that is the behavior you would implement if you want to provide your own exchange. RabbitMQ, again, this is what the behavior you would implement in case you want to provide your own queue customization. On top of that, now, bit of disclaimer, Rabbit queues is where most of the real deal happens, so don't look at these first as long as you don't want to end up in tears. This is a pretty hard behavior to look at, and I'm still learning a lot on top of that. And the last behavior is what you would implement if you want to add a different authentication and authorization mechanism. So, to conclude this talk, I would like to share with you a personal experience when it comes to RabbitMQ plugins. What I was trying to tackle back then was a common problem, especially within our backend, consisting of duplicated messages. And with duplicated messages, I don't mean those messages which are duplicated within the broker due to network errors or any sort of internal error, but rather those messages which from a broker perspective are unique. They come with their unique identifier and timestamp, but from an application or an architectural point of view, they are not. Usually, to each message corresponds a side effect, right? It could consist in a little bit of computation, or it could be a more critical operation such as sending an email or changing some value within a database. And of course, when we see duplicates coming, duplicate side effects, they might have very, very big implication within our architecture. To give a concrete example, let's think about e-commerce website where the UI for some reason freezes or gets sluggish, and and our customer nervously click on the buy button multiple times, right? From the broker perspective, these are all different unique messages, but from our business case, we probably don't want to end up charging our customer multiple times and shipping multiple times the same product, right? The way this is usually tackled was very well introduced by Jack in the previous presentation. So on the consumer side, we add a little bit of logic, usually relying on a local or distributed cache. So anytime we receive a message on the consumer, we check the local cache and we decide, do we actually process this message or not? Now, this is not inherently a wrong approach, but again, as I said before, what we end up doing is grabbing a responsibility, a feature, and scatter it across the whole architecture. So this is a difficult thing to get right. There are many, many corner cases to take care of, and also race conditions, which usually are very tricky because they show later on in your architecture, and you'd end up wasting a lot of time investigating. So what I asked myself back then was, as the broker is actually the central point where all the messages are passing through, why not just implementing a similar mechanism, drop it inside an Erlang process, run it alongside with a RabbitMQ broker, using the behavior I subscribe to the events which happen within a broker, so that I get called every time a new message either gets on my exchange or in the queue, and then I check, hey, should this message actually move forward or not? And this is what I did. I built a Deduplication plugin in Elixir. I think that this is one of the first functional Elixir implementation that you can find out there. It's pretty simple. All you need to do is to provide an X Deduplication header, and X content will be checked when you publish it within the broker in a Deduplication exchange or queue. And according to your rules, decision will be made, should this message continue its route or not. So as I said, we can deduplicate either on the exchange or on the queue. We deduplicate on the exchange if we want to drop our messages early on, and we want to drop our messages in a temporal fashion. In other way, we want to say, once you see this message again in the next 5 seconds, minutes, or hours, just drop it. I want to see this message only once within this time window. And we deduplicate on the queue in a little bit different manner. So once the header comes in, we check, is any other message having the same header in the queue? And if so, we don't publish it within the queue. So let me demo this for you. I will use the already running Rabbit broker. I don't need to do very much more on top of that. What I'm about to do here is just running a script which installs the management plugin and the Deduplication plugin, and then brings up some resources so that we can actually start our demo. Now, if we go back to the management plugin, we might need to refresh it because we killed the previous broker. And once we look at the exchanges, we can see that there's a new Deduplication exchange of type XMessage Deduplication. So when we create an exchange, one of the mandatory arguments we need to give is the cache size, because of course we cannot deduplicate everything forever, right? And then we can provide an optional cache TTL. So this is how we specify our temporal window is optional, so it can be virtually forever, or as long as the cache doesn't rotate our headers. And in this case, it's in milliseconds, so what we're doing is using a temporal window of 10 seconds. We bound this actual exchange to a test queue, which, as long as I know, should be empty, as we can see. And now we can try it out. If I manage to get scrolling on this page, what happens? Let me see. Can I actually scroll down? Okay, yeah, some glitch on the management console. So all I need to do, as I said before, is providing an X Deduplication header. We will put a value test. And what we do is publishing this first message, which should go through, and then we quickly publish a second one, and we should be informed that the message didn't go through. So the first message gets successfully published, and if we go quickly enough, thank you, if we go quickly enough, the second message got actually published but did not move through. If we inspect the queue, we should actually see that we only have one message in our queue, so demo successful. As I said, it's a 10 seconds TTL, so hopefully 10 seconds already passed. So let's try again. We put again our test, and now this message should go through because actually its TTL should have expired. So if we try to publish the message, Again, our message now went through. So this is how we can say, hey, I don't want to see within my architecture the same message for the next 10 seconds anymore. If we look at the queues, we have 2 messages as shown. For those who loves performance, as I have a bit of time, let me show you something more. So this is a Python script, and what we'll simply do is hammer the broker with 10,000 messages, all having the same deduplication message. It's a different one than the one I showed on the broker, on the management console. And as you can see, it's pretty fast. And if we look now at the exchanges, we should see, well, pretty good 1,000 messages going through in my small laptop, which is pretty good value. And hopefully, as expected, our queue end up with only 3 messages. So I'm showing here only the deduplication level. As you might guess, the queue works pretty similarly, so it doesn't really make sense to demo it. And we can move to the conclusion for this talk. So I hope it was clear to you that getting started is really easy once you know how to do it. And this is why I wanted to give this talk, because I find that the biggest barrier for a developer when trying to develop on top of a new technology is how do I get started, all the bureaucracy, like how do I build, how do I find the resources and the rest. So I hope that it's clear how simple it is actually to get going and start playing with code, which is usually what is more interesting. If you look on the web, you will realize that most of the RabbitMQ plugins are pretty simple. They consist of very, very few lines of Erlang code wrapped within a process. And what Erlang does via the supervision sort of behavior is ensuring that your process will be restarted if it's crashing. So you don't really need to fear at the beginning if your plugin crashes or has any problem. It usually does not end up hindering the rest of the broker infrastructure. I really like the fact that there are 2 supported languages now, Erlang and Elixir. I think that this will actually extend the amount of developers which could potentially become contributors. Especially Elixir is a more modern language, comes with really nice tutorials and documentation, and it was built by people which were really inspired by Ruby and Python. So if you're familiar with those languages, you should find a lot of analogies on top of the Elixir language, and it is actually fully compatible with Erlang, so you can reuse everything that Erlang already did beforehand. And on the last point, I would like to make one note. I think it was a very good learning experience for me, but I would like to make one note regarding Erlang specifically. So when I talk to people about developing Rabbit plugins, for example, the usual answer is like, yeah, but it's built in Erlang, right? And let me tell you that in the past I studied quite few languages because I like languages. I'm a curious guy, so I like to look at those things. And I need to say that Erlang has been the only language, or the language which taught me the most beyond the syntax and the semantics itself. Erlang is a language built by very, very brilliant guys which were focusing on very, very hard problems, distributed applications, scalable over very big and problematic networks. And while studying Erlang, what you realize is that in there you will find a lot of those architectural patterns which we usually end up using within our distributed architecture. They're there in the code, and you will learn even more patterns, even more corner cases to tackle. So I need to say that as a developer and as an architect, Erlang might be not the language you end up using on your daily life at work. I never written a single line of Erlang code at work, but it's still one of the languages I believe will bring you the most in your daily work beyond the simple syntax. And that should be everything from my side. I'll just include a few references I used to build this talk. Of course, the documentation. A lot of thanks to the blog post or to the author of the blog post in there. That's what got me unstuck when I was really desperate on how to build Elixir, how to use Mix and Erlang MK at the same time. And at the bottom, I will make sure that these slides are available. That's an empty repository right now, but in there you will find the slides, the code to build them, as well as the examples I've been showing you. So thank you for your attention.
Thank you. And we have some time for questions. So fire away.
Could you comment on how easy or hard it is to build sort of distributed plugins? Because of course the thing works in a cluster normally in production. Is that easy, difficult?
Sorry, can you repeat how easy it is to?
To build plugins that work in a cluster of rabbits.
Okay, well, Rabbit internally relies on the Amnesia database, so what I ended up using is heavily the Amnesia, especially when it comes to distributed caching. As you might guess, exchanges are actually distributed across the whole architecture. So I quickly relied on Amnesia in order to make sure that each and every exchange copy of the same exchange is actually looking at the same data. So I would recommend starting using that rather than using external libraries and application. But of course, you can do that as well. There are quite few, for example, distributed caches implemented in Elixir, so you might want to look at those. I think CacheX is one of those which I was trying initially. So.
I'll stick one question in. What do you think is missing from this ecosystem of plugin development?
Right. Well, I wish there was a little bit more documentation, especially minimal example. I think that what Rabbit provides is one of a reference plugin called Metronome, I believe. And that's pretty complicated, brings in a lot of things. So what I really like to do personally when I start with a new technology is having a minimal example so that I'm not hanging, wondering, is this actually needed? Is this needed in my application? So some more minimal example, and of course more documentation on the behaviors, especially. The queue behavior that I showed before is lacking a lot of documentation. There are a lot of those callbacks or functions to be implemented, which, for example, are for internal use only, and I just recently discovered it on my own skin. So better described in data types, how they're used on top of the behaviors themselves. And of course, more behaviors mean that we can hook in more features into the broker. Yeah.
So if I'm thinking I want to develop a plugin, but
Yeah.
I don't want to kind of destroy the cluster, I'm not so confident, what can I do to kind of limit damage if I'm, like I don't want my plugin to run out of memory and things like that. Is there any controls?
Well, Erlang does a pretty good job in isolating applications. So what you usually start doing is wrapping your logic in an Erlang process, and those processes are different from operating system level processes. They're very lightweight and completely isolated in terms of memory address space. They can communicate only with messages with the rest of the architecture. So I find this very handy because when your process actually crashes, as long as you didn't change some value and left some database schema dirty, usually what you observe is that just the broker cannot provide your feature anymore, but the rest of the component remains. Of course, this is not always true. I managed to crash the broker plenty of times pretty badly, and I also had some people which actually were trying my plugin in production straight away, and they got the production server actually unusable. So, of course, pay attention to the usual practices and stuff. On top of memory consumption, at least, or resource consumption, I don't think that there's much more you can do apart from the usual patterns. So, like, provide a mandatory limitation for cache and check the resources that you're using. Of course, Amnesia has, Rabbit, especially using the management plugin, collects a lot of metrics. So you can also use those to actually understand, am I consuming too much? Am I actually bothering the cluster? So, yeah.
Thank you.
There was a question there, I believe.
Thank you. Do you have to deal with message serialization and deserialization when talking to the broker?
Hopefully, or luckily, so far, not really. most of the time, even though we process a sheer amount of data, it is usually pretty slow. In a sense that, for example, what we usually ingest is 500,000 new files every day that we need to categorize. Now, the heavy part is the categorization. It's not really the message passing and such. So our clusters usually are pretty small. When it comes to serializing and deserializing, we mostly rely on JSON. That's where we pay our costs. So even when we think about our stream of events, they're usually consisting in JSON snippets, which comes already sanitized from our front ends. Also because, of course, we are a security company, we need to gather a lot of data, and we need to be GDPR compliant. We're really paranoid when it comes to the privacy of our customers. So what happens is that a lot of data is sanitized and cleared at the front end so that we could see certain things like the geolocation of who tries to reach us, but we don't see anything else. And so while we're doing that process, we make sure that our data is when reaches the backend, is pretty sanitized. Also for security reasons, you don't want to deal with malicious data across your infrastructure.
I was thinking about the plugin interface.
Well,
when you talk to a hook in the broker.
Yeah, you don't, like most of the times, as was already said before, for example, if you use the headers, those are deserialized for you. So what you just limit yourself doing is specifying which type of data you're expecting. Is it a number, is it a Boolean, or is it a string, right? I would highly recommend not to actually check the body and try to deserialize that yourself. So rely on what the protocol provides you, especially message properties and message headers. That's why, for example, I use the header in there. So you can deduplicate by providing whatever object you want is a string. Usually just put a string and you can deduplicate like that. The broker provides very, very good data types and facilities for you already. So it's pretty easy.
We have time for one more question. Then I'll ask one question. Do you think there's anything that can be done to make it more visible which plugins there are out there in the ecosystem?
That would be actually a very good idea. There are some plugins listed on the main Rabbit web page. I think they're organized in two different pages, those which are maintained by the core team and those which are provided by the community. I tried to reach, but actually was on a chat, so probably got lost within the noise. But it's not clear what makes a plugin looking like official or maintained. So having at least tracking for this type of thing. Is this actually still valid? As we saw in the slide I showed before, I was not sure that everything I included there is still maintained. So yeah, more tracking would really help the community, especially understanding, hey, is this something the broker already provides? That would be really nice. Yeah.
Okay, let's thank Matteo.
Thank you.